In this lesson, we are going to look at our number system and classify numbers and categorize them in different, with names and different categories. And so what we're going to first talk about is our real number system. Okay? Our real number system is basically all of the numbers we know that we use every day. It could be things like pi, it could be things like 8, it could be a quarter. It can't be things like the square root of a negative, right? Because that is not a real number. So the only thing that is not in our real number system are the square roots of negatives and, adding, subtracting, multiplying with those non-real numbers or imaginary numbers. So we're going to focus today on our real number system and classify within them. So there's two groups. If you're a real number, you are either or, but not both. You are either irrational or you are rational. There's two different groups. Okay, so we're going to start with irrational. What is an irrational number? What kind of numbers go there? Okay, so the numbers that go to irrational numbers, there's lots of different ways you can define it here to help us understand it. The main idea is all numbers that cannot be written as a fraction. Okay, so how do we know if a number can be written as a fraction or not? Okay, for example, 0.5 can be written as a fraction because it is 1/2. Right? 7 can be written as a fraction because it's 7/1. Okay, 0.3 repeater is a fraction. Repeating numbers are a fraction. They can be written as 3/9 or 1/3. So those are all numbers that can be written as a fraction. So how do we know numbers that cannot be written as a fraction? Well, there's two main ideas that'll help us. Number one, if your decimal is non-repeating and non-terminating, such as pi. Pi is an irrational number. Its decimal goes on forever and does not have a repeating pattern. Okay? The other rule I like to use is non-perfect roots. For example, the square root of 3. 3 is not a perfect square, and when you take the square root of it, you get a decimal just like pi. It does not stop and has no repeating pattern. Okay? Square root of 4 becomes 2, so that is rational, right? But non-perfect roots, are irrational numbers. Okay, when you type it into your calculator, it only gives you 8 decimal places because that's all the room they have. So your calculator rounds off to the nearest 8th decimal place. But in theory, these decimals do not terminate and go on forever with no pattern. All right, so that's how I know if it's irrational. Okay, if it can't be written as a fraction. Or in other words, its decimal goes on forever with no pattern, and all non-perfect squares have this characterization, this property, I should say. Rational numbers. Let's go to rational numbers. So if it's not irrational, then it's rational. It's one of the two. Okay, and within rational numbers, we can further categorize. Okay, so there's natural numbers. Rational numbers can be further categorized into natural numbers, which are counting numbers. It starts at 1, goes 1, 2, 3, 4, 5. Our whole numbers, which are counting numbers including 0. So really, whole numbers and natural numbers are almost identical. Whole numbers just have 0 as well. Our integers are like our counting numbers and our whole numbers, except they go into the negative direction as well. -1, -2, -3, etc. Okay, everything else is not categorized any further. It's just a rational number, right? So think of these as like fishing nets. The natural numbers have the largest hole. The whole numbers have the next largest hole, a little bit smaller. Integers have even smaller. And everything else goes through and sits in the rational number bin. The only thing this first net catches is your natural numbers, your 1, 2, 3, 4. So everything else falls through. Okay, so in the natural numbers net, you have your numbers 1, 2, 3, 4, and 5 and up. In your whole numbers, none of your natural numbers came through, but it only catches whole numbers. So what's sitting in this fishing net? In your whole numbers fishing net? pretty much there's only one number, because everything that's not a whole number or natural number goes through the holes and goes into your integers. So the only number that's sitting there is 0, right? Because your natural numbers, all your 1, 2, 3, 4, 5, 6, 7, 8, those already been caught in that net. 0 sits in your whole numbers net. And then your integers net catches all your integers, right? But none of your whole numbers made it. None of your natural numbers made it to your integers net. So all of your -1, -2s, -1s, -2s, -3s, those have all get caught in the integers net, right? Everything else filters through into your rational numbers. So all of your decimals like 0.25, your repeating decimals, your fractions, they're all sitting there. So that has a lot of numbers in that, okay? So rational numbers are anything that can be written as a fraction. In other words, its decimal has a repeating pattern, or its decimal terminates, or it's a whole number, a natural number, or an integer, right? So let's look at that. So let's place the best category, okay? So -3 is an integer. It's not a whole number. It's not a natural number, but it's an integer within your rational number, rational bin. So this is a rational number. I use Q for rational. The reason why I use Q for rational is because Q stands for quotient, right? And quotient means it can be written as a fraction, right? Fraction means to divide, right? Q with a line on top means not Q or not a quotient. So it's irrational. So it's either rational or irrational. If it is rational, it can be further categorized, okay? 5 is rational, and it can be categorized into a natural number. 0 is rational, and it can be categorized into a whole number. 1/2 is rational, but it cannot be further categorized. Root 79 is actually 7, so it's rational, and it can be categorized as a natural number. Pi is irrational. 0.84, since it's a repeating pattern, it's rational but cannot be further categorized. Root 2 is not a perfect square, so it is irrational. 27 is a perfect cube because it's -3, -3, -3, so the cubed root of -27 is -3. Therefore, it's rational, and it can be further categorized as an integer. Cubed root of 9 is not a perfect cube, so therefore it's irrational. The square root of 1/9 is 1/3, so it is rational, right? If your fraction, if your numerator and your denominator are perfect squares, it's rational. Here we have a pattern, but it's not a repeating pattern, so it's irrational. Okay. If I threw a number like this in, you would say it's not rational or irrational. It is neither. Right? So sometimes you can have it not being rational or irrational if you're taking the square root of a negative. Okay? And of course, there's our little joke of the day. Our non-real number is telling our irrational number to be rational, and our irrational number is telling our non-real number to get real. Ha, ha, ha. There we go. So, your assignment for today is going to ask you, tell me if it's rational, irrational, or neither. Okay? So if it's not a perfect square or not a perfect cube, it is going to be irrational. If it has a pattern that does not repeat, does not have a repeating pattern, it is irrational. Okay? If it terminates, it's rational. Right? This is the same as 5 times 2. 4 is a perfect square, therefore it is rational. I'm not asking you to further categorize rational, I'm just saying rational, irrational, or neither. Okay? If you're taking the square root of a negative, it is going to be neither. Okay, so you need to be able to go through and classify as rational, irrational, or neither. Okay, can you take the cubed root of a negative? Yes, you can, so that's a real number. But is 100 a perfect cube? No, it's not, so it's irrational. Okay, so you have to think it through. If it's a fraction, it's real. Sorry, it's rational. Well, they're all real. It's rational. So I would say it's a rational number. All right? You should be able to put numbers on a number line. So the square root of 18, where would I put that on my number line? Well, you can just need to be able to type in the square root of 18 on your calculator and say, well, that's approximately, even though it's irrational, I know it's approximately 4.2. So I have to go to 1, 2, 3, 4. So there is the square root of 18. You can place these numbers on your number line. If I give you negative 4 root 2, you know that means negative 4 times the square root of 2. Type that into your calculator and say, oh, that's approximately negative 5.66, or about negative 5.7. 1, 2, 3, 4, 5, a little over half. So there's negative 4 root 2. So you can place your irrational numbers on a number line where their approximation is equal to. All right, so that is rational and irrational numbers. You should also be able to use your calculator to type in the cubed root of numbers. If the negative's on the outside, you just apply it. The cubed root of 17 is approximately 2.6. So I bring down that negative, so it's going to be approximately negative 2.6. And you can put that on your number line.